Picture this. You're standing in front of a stone wall that weighs more than 20 elephants, and somehow, using nothing but rope, wood, and pure human determination, you need to lift it 200 feet into the air. No cranes, no bulldozers, no power tools. Just medieval ingenuity and enough faith to move mountains, literally. Welcome to the most ambitious construction project of the 1200s, building a Gothic cathedral. These weren't just big churches. We're talking about engineering marvels that made the pyramids look like warm-up exercises. The average Gothic cathedral took longer to build than most civilizations lasted, cost more than entire kingdoms could afford, and required solving structural problems that would make modern architects break out in cold sweats. Yet somehow, using techniques that sound more like magic tricks than construction methods, medieval builders created soaring spaces filled with light that still take your breath away 800 years later. Here's what blows my mind about these projects. The master builders had no concrete, no steel, no computers to calculate stress loads. What they had was an understanding of stone, geometry, and physics that was so precise they could stack rocks 300 feet high without the whole thing pancaking into rubble. They figured out how to make walls so thin they were practically see-through, then filled those walls with stained glass windows that told stories in light and color. It's like they took everything we think we know about building and threw it out the window, then built the most beautiful windows in history to replace it. The sheer audacity of these projects is mind-boggling. Imagine walking into a town meeting in 1200 and announcing, "Hey, let's build something taller than anything that's ever existed. Make it entirely out of stone. And oh yeah, it'll only take us about a century to finish. Who's in?" The fact that entire communities said yes to this insane proposition tells you something about medieval priorities. These people were willing to commit their great-grandchildren to construction projects they'd never live to see completed. But before anyone could start hauling stones or mixing mortar, someone had to figure out exactly what they were building. Cathedral planning in the 1200s was like playing three-dimensional chess with your city's entire future. The master mason, basically the medieval equivalent of a chief architect and project manager rolled into one incredibly stressed-out person, had to create a building that would inspire awe, house hundreds of worshippers, survive earthquakes and storms, and somehow not collapse under its own impossible weight. The first step was picking the perfect spot. This wasn't just about finding a nice piece of real estate. Cathedral builders were obsessed with orientation. The building had to face east toward Jerusalem, with the altar positioned to catch the first light of sunrise. They'd spend weeks surveying potential sites, checking drainage, soil stability, and access to building materials. One wrong calculation here could doom the entire project before the first stone was laid. Once they'd chosen their spot, the real fun began, creating the ground plan. This wasn't something you sketched on the back of a napkin. Master masons would literally draw the entire cathedral floor plan full size on the ground, using nothing but ropes, stakes, and an almost supernatural understanding of geometry. Picture trying to draw a perfect circle the size of a football field, using only a piece of string and a wooden stake. Now multiply that complexity by about 1,000, because Gothic cathedrals were geometric masterpieces with every arch, every column, every flying buttress calculated to mathematical perfection. The tracing floor became the medieval equivalent of architectural blueprints, except these blueprints were massive drawings carved into stone or plaster. Master masons would create full-scale templates for every single architectural element: arches, capitals, window tracery, you name it. These patterns were so precise that stonemasons working on opposite sides of the building site could cut matching pieces without ever seeing each other's work. It was like having a medieval instruction manual, except instead of assembling furniture, they were assembling buildings that would outlast empires. The mathematical precision required for this planning phase was absolutely staggering. Gothic builders used a system of proportional relationships based on simple geometric shapes, squares, triangles, and circles, but applied them with a sophistication that would impress modern engineers. They discovered that certain mathematical ratios created spaces that felt harmonious to the human eye and ear. The same proportions that made the building look beautiful also made it acoustically perfect for Gregorian chant. But all the planning in the world meant nothing without the right people to turn those plans into reality. Cathedral construction required assembling what was essentially a medieval dream team of craftsmen, each with skills that took decades to master. At the top of this pyramid sat the master mason, a figure who combined the roles of architect, engineer, project manager, and occasionally diplomat when things went sideways with the church authorities. The master mason wasn't just some guy who was good with stones. These were elite professionals who commanded salaries that made them wealthier than most nobles. They traveled from project to project across Europe, bringing with them not just technical knowledge, but entire networks of skilled craftsmen. When a master mason accepted a cathedral commission, he was basically agreeing to spend the next 30 years of his life turning someone's impossible dream into stone and mortar reality. Working under the master mason was something called the lodge, a tight-knit community of specialized craftsmen who lived and worked together for decades. The stone cutters were the rock stars of this operation, capable of carving intricate decorative elements with precision that would make modern sculptors weep with envy. These guys could look at a rough block of limestone and see a delicate capital or a grinning gargoyle hiding inside, then coax it out with nothing but hammers and chisels. The carpenters were equally crucial, responsible for creating the massive wooden frameworks that supported stone arches during construction. They built scaffolding systems that rose hundreds of feet into the air, temporary wooden cathedrals that held up the real stone cathedral until the mortar cured. One mistake in their calculations, and the whole project could come crashing down, literally. Then there were the smiths, who forged not just tools, but architectural elements. Medieval cathedrals used thousands of iron clamps, ties, and reinforcements to hold everything together. The glaziers created those stunning stained glass windows, mixing colors from recipes that were closely guarded trade secrets. Each craft had its own mysteries, its own techniques passed down through generations of masters and apprentices. The apprentice system was how all this knowledge survived and spread. Young men would spend 7 years learning their trade, starting with the most basic tasks and gradually working their way up to positions of responsibility. By the time they became masters themselves, they'd absorbed not just technical skills, but the entire culture of cathedral building. It was like a medieval university program, except instead of getting a diploma, you got the ability to transform stone into architecture that would inspire people for centuries. This whole system created something unique in medieval society. A mobile community of highly skilled professionals who operated according to their own rules and traditions. The lodge wasn't just a workplace. It was a brotherhood with its own codes of conduct, its own ceremonies, and its own ways of protecting trade secrets. These weren't just construction workers. They were the guardians of architectural knowledge that made Gothic cathedrals possible. The most fascinating part about this medieval construction crew was how they solved problems that shouldn't have been solvable with 1200s technology. They figured out how to coordinate the work of hundreds of people across decades-long timelines. They developed quality control systems that ensured stones cut in different quarries would fit together perfectly when assembled on site. They created management structures that could survive changes in leadership, funding crises, and even wars. But having the right team was only the beginning. Before anyone could start building upward, they had to master the art of working with stone, from the moment it was blasted out of distant quarries to the second it was set in place 200 feet above the ground. The stone itself was where the real magic happened. And let me tell you, medieval quarrying was like performing surgery with sledgehammers. These weren't your modern precision operations with diamond-tipped saws and hydraulic splitters. Cathedral builders had to work with what nature gave them, using techniques that were part science, part art, and part sheer stubborn determination. Finding the right stone was like dating, except instead of looking for personality compatibility, you were searching for limestone that wouldn't crumble under pressure, or sandstone that could handle 2 centuries of weather without turning into expensive gravel. Master masons would travel hundreds of miles to find quarries with just the right properties. They needed stone that was soft enough to carve intricate details, but hard enough to support massive loads. Too soft, and your gargoyles would melt in the first rainstorm. Too hard, and your stone cutters would go insane trying to carve anything more complex than a basic block. The quarrying process itself was absolutely brutal. Workers would identify natural cracks in the rock face, then widen them using a technique called fire setting. They'd build fires against the stone, heating it until it expanded, then douse it with cold water to create thermal shock. The sudden temperature change would split the rock along predictable lines, assuming you got the timing right. Get it wrong, and you'd either get useless fragments or waste days of work heating stone that refused to cooperate. Once they'd extracted rough blocks, the real artistry began. Each stone had to be shaped to exact specifications, and we're talking about tolerances that would impress modern engineers. A single cathedral might require 50,000 individually cut stones, each one slightly different, but all fitting together like pieces of the world's most complex jigsaw puzzle. The stonecutters would work from those full-scale templates created during the planning phase, but they still had to adapt each block to the natural variations in the raw material. Here's where things get really impressive. Every single stone was numbered and labelled before it left the quarry. Medieval builders had developed a coding system that told them exactly where each piece belonged in the finished structure. It was like flat-pack furniture instructions, except instead of assembling a bookshelf, they were putting together a building that weighed more than the Titanic. Stonecutters would chisel small marks into each block, cryptic symbols that served as medieval GPS coordinates for the construction site. The logistics of moving all this stone were mind-bending. We're talking about transporting millions of tons of rock using nothing but ox carts, river barges, and human muscle power. A single column capital might weigh 3 tons and require a team of 20 men just to load onto a cart. The average cathedral used enough stone to build a small mountain, and every pound of it had to be hauled from quarries that were often dozens of miles away. Rivers became stone highways during cathedral construction. Builders would time their quarrying operations to coincide with seasonal floods, when rivers ran high enough to carry heavily loaded barges. Some quarries were chosen specifically because they had water access. It was cheaper to move stone by water than overland, even if the quarry itself wasn't ideal. One famous cathedral project built a canal system just to transport their building materials, essentially rerouting geography to serve their construction needs. But getting the stone to the construction site was only half the battle. Once it arrived, every block had to be inspected, sorted, and stored until it was needed. Cathedral sites became massive outdoor warehouses, with carefully organized piles of numbered stones waiting their turn to become part of something magnificent. Master masons developed inventory systems that would make modern logistics managers proud. They knew exactly how many arch stones they had in storage, which blocks were ready for immediate use, and what pieces were still being cut at distant quarries. The mortar that held everything together was its own engineering marvel. This wasn't just cement mixed with water. Medieval builders had discovered that certain combinations of lime, sand, and additives created bonds that actually got stronger over time. They'd burn limestone in massive kilns, creating quicklime that had to be slaked with water in a process that generated enough heat to cook an egg. The resulting lime putty would be aged for months or even years before being mixed with carefully selected sand to create mortar. Different parts of the cathedral required different mortar recipes. The foundation needed mortar that could resist ground moisture. The upper walls required lighter mixtures that wouldn't add unnecessary weight. The decorative stonework demanded fine-grained mortar that could be shaped and carved almost like stone itself. Some master masons guarded their mortar recipes as closely as modern companies protect their trade secrets. The wrong mixture could compromise the entire structural integrity of the building. The curing process was equally critical. Fresh mortar needs time to reach its full strength, but cathedral builders couldn't afford to wait months between each course of stones. They developed techniques for accelerating the curing process, using heat, humidity control, and additives that helped the mortar set properly even in cold weather. Some builders would actually schedule construction activities around seasonal weather patterns, knowing that mortar laid in winter might not reach full strength until spring. All of this stone preparation and mortar mixing was just the groundwork for the real challenge: getting massive blocks of carved stone into position hundreds of feet above the ground. And that's where medieval builders had to become masters of physics, engineering, and what can only be described as controlled falling. The lifting systems they devised were masterpieces of mechanical engineering that would make Leonardo da Vinci jealous. The star of the show was something called a treadwheel crane, basically a giant hamster wheel operated by human power instead of rodents. These contraptions could lift loads of several tons, using nothing but the weight and muscle power of men walking inside a large wooden wheel. Picture a Ferris wheel laid on its side, with workers climbing up the inside like they're running on the world's slowest treadmill. The physics behind these cranes was actually brilliant. By using the weight of the workers as a counterbalance and multiplying their force through a system of pulleys and gears, a team of 4 men could lift stones that would normally require 20. The larger treadwheel cranes could hoist blocks weighing up to 10 tons. That's the equivalent of lifting 2 full-grown elephants using nothing but human power and medieval engineering. But the cranes were just one part of an elaborate lifting ecosystem. Cathedral builders created networks of ramps, scaffolds, and temporary bridges that turned the construction site into a 3-dimensional maze. Stone blocks would travel complex routes from ground level to their final positions, sometimes being passed from crane to crane as they climbed higher up the building. Workers developed hand signals and calling systems to coordinate these operations. One miscommunication could send a ton of carved stone plummeting to earth, taking out scaffolding and possibly workers in the process. The scaffolding systems alone were engineering marvels. These weren't simple wooden platforms. They were temporary wooden buildings that rose alongside the stone cathedral. Master carpenters would design scaffold frameworks that could support not just the weight of workers and materials, but the dynamic loads created by swinging stones and operating cranes. Some of these wooden support structures were so elaborate they required their own foundations and stayed in place for decades. Safety was a constant concern, though medieval safety standards were somewhat different from modern ones. Workers routinely performed tasks at deadly heights, with no safety equipment beyond their own skill and courage. The mortality rate among cathedral builders was frighteningly high. Falling stones, collapsing scaffolds, and simple slips from high platforms claimed lives regularly. Yet somehow, these projects attracted workers who were willing to risk everything for the chance to create something that would outlast their great-grandchildren. The workday on a cathedral site started before dawn and didn't end until darkness made it too dangerous to continue. Workers would arrive as the first light hit the scaffolding, carrying their tools and whatever breakfast they could afford. The sound of hammers on chisels, creaking ropes, and shouted instructions would echo through the town for the next 12 hours. These weren't 8-hour shifts with coffee breaks. Cathedral building was a sunrise to sunset commitment that demanded everything from the human body. What made these daily operations even more incredible was how they coordinated hundreds of workers across multiple levels of a building that was constantly growing upward. Stonecutters on the ground level had to stay weeks ahead of the masons working on the walls, who had to coordinate with the crane operators, who had to time their lifts with the mortar mixers. It was like conducting an orchestra where every musician was playing a different song. But somehow the whole thing had to come together in perfect harmony. The real genius of Gothic architecture wasn't just in how they lifted heavy stones. It was in how they made those stones work together to create something that seemed to defy gravity itself. The secret lay in understanding forces, and medieval builders had figured out principles of structural engineering that wouldn't be formally written down until centuries later. The pointed arch was their game changer. Unlike the round arches used by the Romans, Gothic pointed arches directed weight and pressure downward more efficiently. Instead of pushing outward against the walls like Roman arches did, pointed arches channeled forces straight down to the ground. This meant the walls didn't have to be massive fortifications. They could be relatively thin curtains of stone held up by a skeleton of arches and supports. But the real magic happened with the rib vaults. Picture the ceiling of a Gothic cathedral, those elegant stone ribs that seem to flow from the columns like frozen waterfalls. Those aren't just decorative, they're the building's structural nervous system. The ribs carry all the weight of the roof and distribute it to specific points on the columns below. Between the ribs, the stone ceiling could be relatively thin and light because it wasn't bearing any major loads. This is where flying buttresses come into the picture. And these things are absolutely brilliant. The high walls of a Gothic cathedral wanted to push outward under the weight of the stone vaulting above. Flying buttresses were like stone arms reaching out from separate supports to hold those walls in place. They transferred the outward pressure from the walls to heavy buttresses built away from the main structure. It was like having invisible hands holding up the building from the outside. The engineering math behind all this was sophisticated enough to make modern architects respect their medieval predecessors. Each flying buttress had to be precisely positioned and angled to intercept the forces coming from specific points on the main structure. Get the angle wrong by just a few degrees and the buttress would be useless. Or worse, it might actually contribute to the building's instability. What's really mind-blowing is that medieval builders figured all this out through trial and error, mathematical intuition, and probably more than a few catastrophic failures. They didn't have computer models or stress analysis software. They had geometry, experience, and an understanding of how stone wanted to behave under different conditions. When something didn't work, they'd adjust the design and try again, assuming the building didn't fall down first. The timberwork above all this stone architecture was equally impressive and far more dangerous. Cathedral roofs required enormous wooden frameworks that had to span distances that would challenge modern engineers. These timber trusses were essentially wooden bridges turned upside down, carrying the weight of lead roofing across spaces that could exceed 100 feet without any intermediate supports. The carpenters who built these roof structures were working with trees that had been growing for centuries. They'd select oak timbers based on the grain patterns and natural curves of the wood, using the tree's own growth patterns to create stronger joints and supports. Some of these timber frameworks used joints so complex they looked like wooden puzzles. No nails or metal fasteners, just wood fitted to wood with tolerances measured in fractions of inches. Fire was the constant terror hanging over these wooden roof structures. A single spark from a candle or lightning strike could turn centuries of work into an inferno that would consume not just the roof, but threaten the entire building. Cathedral builders developed elaborate fire prevention systems, including stone walls that separated the wooden roof structure from the main building spaces below. The lead roofing itself was another logistical nightmare. Lead sheets had to be cast, shaped, and soldered together to create a waterproof skin over the entire cathedral. We're talking about thousands of tons of metal that had to be hauled up to roof level, then worked by craftsmen who were essentially doing metalworking while balanced on narrow wooden beams hundreds of feet above the ground. But perhaps the most spectacular achievement of Gothic cathedral building was the stained glass. Those glorious windows that transformed ordinary daylight into something that seemed to come directly from heaven itself. Creating these windows required mastering techniques that were part chemistry, part artistry, and part pure magic. The glass itself was made in furnaces that burned hot enough to melt sand and ash into a molten liquid that glowed like captured sunlight. Different colours required different chemical additives: cobalt for blue, copper for red, silver for yellow. The glassmakers guarded their colour recipes like state secrets, and many techniques were lost when master glaziers died without passing on their knowledge. The most prized glass was called pot metal, where the colour was mixed into the molten glass itself, rather than painted on the surface. This created colours that seemed to glow from within, with depths and variations that painted glass could never match. A single window might contain hundreds of individual pieces of pot metal glass, each one cut and shaped by hand to fit the overall design. The leading that held these glass pieces together was almost as important as the glass itself. Strips of lead were shaped into channels that gripped each piece of glass, while remaining flexible enough to move with temperature changes and building settlement. The lead work in a large rose window was like a delicate spider web made of metal, holding together a puzzle of coloured light that could contain thousands of individual pieces. Installing these windows required its own specialised skills and equipment. The finished panels were heavy, fragile, and incredibly valuable. Dropping one would destroy months of work and cost more than most people earned in a year. Glaziers developed special lifting techniques and protective frameworks to get these masterpieces into position without shattering them. The scale of the financial commitment required for these projects was absolutely staggering. A single Gothic cathedral could cost more than the annual income of an entire kingdom. Bishops would mortgage church lands, sell relics, and organise fundraising campaigns that lasted for generations. Wealthy merchants competed to sponsor individual chapels or windows, seeing cathedral construction as both a religious duty and a way to ensure their names would be remembered long after they were gone. Guild organisations would pool their resources to fund specific parts of the building. The stone masons might sponsor a particular doorway, while the wool merchants paid for windows in the nave. These funding campaigns created social networks that bound entire communities together around the shared goal of completing their cathedral. The timeline for these projects tested the patience of saints. Most Gothic cathedrals took between 50 and 200 years to complete. Multiple generations of the same families would work on the same building, with skills and responsibilities passed down from father to son. Some cathedrals were started with one architectural style and finished in another as tastes and techniques evolved over the decades. Construction would often pause during wars, plagues, or economic downturns, sometimes for years at a time. The partially completed buildings would be covered with temporary roofs to protect the work already done. Then construction would resume when funding and circumstances allowed. Some cathedrals were never truly finished. They stand today with missing towers or incomplete facades, testament to the ambitious dreams that exceeded even medieval determination. But when things went wrong, and they frequently did, medieval builders had to become masters of crisis management. Cracks would appear in walls, sections would settle unevenly, and occasionally entire portions would collapse without warning. Each failure became a learning opportunity, leading to innovations in buttressing, foundation design, and structural reinforcement. The most famous failures often led to the greatest innovations. When the choir of Beauvais Cathedral collapsed in 1284, builders didn't abandon the project. They analysed what went wrong, redesigned the support systems, and rebuilt it stronger than before. These setbacks were expensive and sometimes deadly, but they pushed the boundaries of what was possible with stone and mortar. Iron reinforcements became increasingly common as builders learned from their mistakes. Hidden iron ties and clamps held critical joints together, while iron rods reinforced spans that pushed the limits of stone's tensile strength. These metal reinforcements were often concealed within the stonework, invisible repairs that ensured the building's survival for centuries. The legacy of Gothic cathedral building extends far beyond the magnificent structures that still grace European cities today. These projects created networks of skilled craftsmen who carried their knowledge across continents. The techniques developed for cathedral construction influenced castle building, bridge engineering, and domestic architecture for centuries. Perhaps most importantly, these cathedrals proved that human beings could accomplish the impossible when they combined technical skill with unwavering determination. Every Gothic cathedral that survives today is a testament to the power of collaborative effort sustained across multiple generations. They remind us that the greatest achievements in human history have always required people willing to start projects they knew they'd never live to see finished. Standing in a Gothic cathedral today, surrounded by stone that was cut by hand 8 centuries ago and lit by windows that still glow with medieval fire, you're experiencing the direct result of thousands of individual decisions to keep building, keep innovating, and keep believing that the impossible was just another engineering problem waiting to be solved. These weren't just buildings. They were proof that human ambition, when properly focused and sustained, could literally reach toward heaven and create something that would inspire awe for centuries to come.